In the modern world, we pursue new and inventive ideas, even when risky, specifically rocketry. Everyone in our team works in rocketry, and we have all seen common issues that make it expensive and dangerous. Despite the efforts of many, rocket motors are still a major problem for hundreds of thousands of rocketry teams across the US. That's why here at RUD Rocket Works, we aim to solve this once and for all.
By Mohit Varikudi, Evan Fielding, Adi Dandekar, and Ayush Reddy.
Nearly all rocketry competitions use rocket motors. These motors are tubes of combustible powder that provide 2 to 3 seconds of thrust. With them come two main issues. First, as each rocket motor costs $10 to $100, tests rapidly increase expenses. These motors aren't reusable as manually refilling explosives can be dangerous. Second, using explosives poses a safety risk and require clearance to use. These are damaging for our customers, the tens of thousands of high school teams whose inexperience and low funds makes aerospace difficult. They often have trouble finding clearance, and each competition buy an average of 23 motors at $18 each for a total of $414 per year. This cost prevents those teams from developing a better competition rocket.
Our solution is a rail-guided, flywheel-operated launching system to launch rockets without the use of a single-use rocket motor. The final product is reusable and has no single-use parts to prevent extra costs. The main idea is to replace the acceleration produced by the rocket motor with a flywheel similar to how Nerf blasters would accelerate a dart, or the mechanism in a roller coaster that pushes the carts up the first drop. Our launching system is designed to be set up in grass and staked to the ground via 8 points of contact, 4 at the base and 4 lines that come out from the top, staked to the ground similar to how you would in a tent. The rail system is designed to be modular and accept different rockets. This was accomplished by using standard aluminum extrusions and a bracket that holds the rocket, and different brackets can be used for different rockets. The flywheel utilizes a design that prevents expansion when spun at full speed, ensuring that it lasts a long time.
In order to ensure reliability with our product, we needed a reliable interface for the system. For this, we developed a custom web interface that allows us, with both Bluetooth, Wi-Fi, and a LoRa chipset that's built into the ESP32 we got, to control the system. This allows us to control flywheel speed, send terminal commands, unlock and set up a launch with the system, ensuring reliability and safety. This allows us for both remote launch as well as remote monitoring.
All design and custom parts are 3D printed. The product is manufacturable due to how it uses a mix of pre-made parts and custom 3D printed parts that are assembled and held together with screws. This could also be a DIY kit due to the simplicity of the build process. The motor, electronics, aluminum extrusions, and hardware are purchased. During large-scale manufacturing, those parts can be ordered in bulk to keep costs low.
There are some issues though. Currently, one of the main problems is the lack of power that is applied to the launch module since the singular motor does not apply enough force, which is addressed by adding more motors on both sides. Another problem is the friction that exists between the launch module and the rail, which can be addressed by separating the rails, allowing the launch module to exit much more smoothly.
The best way to prove that a product is good is to make people spend their hard-earned money on it. So that's exactly what we did. We currently have 5 people down for pre-orders for this device, and with the help of TVA, we begin delivering and producing these by the end of June. Also, thank you to all of our sponsors for helping fund and deliver parts.